Sometimes the biggest, most world-changing ideas, they aren't loud and flashy. And today, we're going to crack open a paper from 1976 that is the perfect example of that. It quietly built the very foundation of our modern connected world. It gave us Ethernet.
So, what in the world does a polite conversation at a dinner party have to do with how your computer connects to the internet? It sounds a little weird, I know, but trust me, that simple analogy is the absolute key to understanding one of the most brilliant and long-lasting ideas in the history of tech. All right, to really get this, we've got to jump in a time machine. Let's head back to the early 1970s, to a place that was basically the epicenter of innovation, Xerox's famous Palo Alto Research Center, or PARC for short. This is where our story really kicks off.
Back then, computers were becoming absolute beasts. I mean, these things were workhorses. They could crunch numbers like you wouldn't believe. But they were basically digital islands. They were lonely. Sure, you could connect them across the country, but that was a huge, expensive project. The new frontier was something that sounds so simple to us now. How do you get them talking to each other in the very same building?
And this is super cool. This table is pulled directly from that 1976 paper. The inventors, Robert Metcalfe and David Boggs, they literally mapped out the problem. On one end, you had remote networks, connecting computers over vast distances, but they were slow. On the other end, you had multiprocessors, components inside a single computer, talking super fast. But look right there, that big gap in the middle, local networks. That was the sweet spot, the exact problem they were trying to solve.
And the solution they came up with? Man, it was a total breakthrough. An idea so clean, so powerful, that we're still using it today.
They gave it this amazing name, Ethernet. And the name itself is this brilliant little clue. It's a throwback to this old, debunked science idea of a luminiferous ether, this invisible, universal medium that everyone thought light traveled through. For Metcalfe and Boggs, their ether was the network cable, a single shared channel that every single computer could connect to. And this, right here, this quote from the paper's abstract, this is the whole game. No central control. Think about that. Most networks back then needed a traffic cop, a main computer telling everyone else what to do. The problem? If that central computer went down, the entire network was toast. Ethernet's radical idea was to just get rid of the boss. They distributed control to every computer on the network.
Okay, so if you get rid of the traffic cop, how do you stop a massive traffic jam? How do you keep dozens of computers from all shouting at the same time? Well, it turns out you just teach them some manners. You teach them how to have a polite conversation.
And to really see why this was so genius, you got to look at what came before it. There was this thing called the Aloha Network, and its strategy was basically just talk whenever you want and, hope for the best. Yeah, you could imagine how that went. Lots of collisions. Ethernet comes along and says, whoa, whoa, whoa. Let's try two simple polite rules. First, listen before you talk. And second, if you do accidentally talk over someone, you both just stop, take a brief pause, and then try again.
And this is the technical term for it, CSMA/CD. Sounds super complicated, right? It's not. It's literally that polite dinner party, step 1, listen first. Is anyone else talking? That's carrier sense. Step 2, if the coast is clear, start talking. Transmit your data. Step 3, and this is clever, keep listening even while you're talking, just in case someone started at the exact same moment. That's collision detection. And if a collision does happen, step 4, everybody stops, waits a random little bit, and then goes back to step 1. It's simple, it's decentralized, and it works incredibly well.
The best part is, this wasn't just some idea on a whiteboard. Nope. The team at Xerox PARC actually went and built this thing. So let's take a look at what the very first Ethernet actually looked like. And again, check this out. This is the original blueprint straight from the paper itself. It's so elegant, right? The ether is just this one long coaxial cable, like a main street, a bus. You could just tap a new computer into it anywhere you wanted. No complex central hub, no single point of failure. It was cheap. It was reliable, and it was beautifully simple. So to make this whole thing a reality, you really just needed 4 main parts. First, you've got the ether. That's the cable itself. Then transceivers, which were the little gadgets that physically tapped into the cable. Third was the interface, the hardware that connected that transceiver to the computer. And finally, the controller. That's the software that made sure the computer followed all those polite conversation rules. So, okay, they built it, it worked. But the real question is, how well did it work?
And why on earth are we still talking about it almost half a century later? Well, that gets us to its incredible lasting legacy. Get this. The speed of that very first experimental Ethernet was nearly 3 megabits per second. I know, your phone is way faster. But you have to remember, this was 1976. For its time, that was blazing fast, more than enough for what any office or lab needed. But this is the stat that just blows my mind. This table, also from the paper, shows how efficient it was under pressure. And just look at those numbers. Even when you had 256 computers all trying to use the network at once, it was still using over 98% of its power for actual useful data. The polite conversation model wasn't just a neat idea. It was unbelievably efficient and stable. And that is the punchline. That's why this matters so much. This core idea, distributed control, no central boss, just a simple set of polite rules, it was so good, so robust, that it's still with us today. It's gotten thousands of times faster, sure, but the fundamental DNA of pretty much every wired network connection you use goes right back to this one paper.
So that kind of leaves us with one last big question to think about, doesn't it? This one simple, elegant idea, teaching computers to talk politely, it literally wired our world together. Just imagine, what would our digital lives even look like without it?